Okay, today we're going to do a review of the SAJ battery, Yorick, or as we like to call it,
Sarge, even if you're not overly interested in SAJ, we've pulled some battery modules apart. We're going to take you through what makes up a battery module. Let's get into it.
Sarge.
Every time we do a battery or inverter review, we've got customers calling us left, right, and center wanting us to install these battery systems. We can't install every battery or solar system we reviewed.
No, not even if we do glowing reviews like we did sort of a review last time on SunGrow. It doesn't mean we're going to install these batteries. We're certainly not going to be installing SAJ or Sarge. Uh, but But there are some things that we do like about this battery, and before we say the negatives, I wanted to cover the positives first quickly.
Okay, so tell me what makes up a SAJ battery?
Okay, so the thing that I do like about it, or I think both of us like about it, is it's a true high voltage battery. So we've gone on about the different ways you can do a battery. You either stack them and then you optimize them and step them up to a high voltage with a DC to DC converter.
Sure.
Or you naturally get them there with a whole bunch of little 3.2 volt cells.
Yeah.
So the SAJ battery has got 32 times 50 amp hour cells in it approximately.
So that works out to be what, about 100 volts per module?
100 volts because 3.2 times 32 is about 102 volts or something like that. So if you have four of those bricks together, by the way, that's 5 kilowatt brick. If you have four of those together, you have 20 kilowatt hours or you have 400 volts. Now the 400 volts, just to recap on what we've said before, is a really important figure, or that's the figure that we roughly want to get to then convert it down to 240 volts AC.
Okay.
And when you do get that figure, naturally, you're just getting a lot more efficient battery.
So these batteries must be very efficient, Mark. You've been doing some round trip efficiency testing on a range of products, and I think we've just finished it with SAJ too.
It does, and no surprises at all. It's pure physics, mate. Is that we got the same as any other high voltage battery. We got sort of 90% on that fast round trip efficiency test and 80% on that slow round trip efficiency test. No surprises there at all.
Let's put the numbers up on the screen, but I think it actually did a little bit better than Fox.
It did a little bit better than Fox, actually. To be fair, we're not nitpicking over the small differences, I think. This isn't lab condition testing, but it is proving that within range, all these batteries, high voltage batteries, are pretty well similar.
Yeah. One of the other things I really like about the SAJ is the cost to performance ratio. They've got a range of products, so you can get anything from a small little 2 or 3 kilowatt inverter all the way up to the 30 kilowatt. We actually got to see both. So we installed a 10 kilowatt single phase, and we've got a friend in the industry who's got a 30 kilowatt monster of a SAJ inverter and battery system.
Yeah. Both of them are good. They've got the full range of everything you need. 20 kilowatt hour stacks on single phase, 25 on three phase, which is plenty big enough. They've got really good pass-through current, which means you can do whole-of-house backup without getting too caught up in it.
Yeah, we learned that lesson with Fox, didn't we?
Exactly. So decent inverter, decent sort of lineup of packages and offering. They've been in Australia for 6 years now, which is like 3 times longer than some company. So it doesn't seem like forever, but it's been here long enough to establish a service department.
Yeah, and the company's been around for some time now too. So the company's been around for about 20 years, and they actually specialize in frequency controllers for electric motors. So this is for constant pressure water pumps, factory automation. So when you want to really have fine control over electric motors. So yeah, it's interesting that they do that, because they actually might show us why we see some things in a in an SAJ system that we don't see in other brands.
Yeah. So two things we bang on about is high voltage batteries, which we've got tick, and tech support.
Tech support.
So we've got local tech support. So shout out to Terry in Brisbane. That helps us out and helping with a lot of these as we're going through the testing of this.
Yep. And they pick up the phone too. So we called them twice today.
And called them yesterday as well a couple of times.
Yep.
Up straight away.
Yeah, they picked up for me 2 or 3 rings in. But funny story. So we thought we'd just give the tech support a bit of a test.
Mystery shopping.
Mystery shopping, do a little bit of make up a bit of a fake scenario. And anyway, they bring up the inverter. They say, yeah, everything's looking normal, but you're at the older software. We'll do a software update, and that should fix your mystery problem. Well, the thing is, the inverter and battery system worked before the update, and it has been offline for over 4 hours now. So, I think
the irony is there wasn't even a problem. You were just mystery shopping.
So yeah, we'll get that up and running. We'll actually put a note in the video as to what the result of it is. Hopefully, it is an easy fix and just needs a restart. into it.
It wouldn't be the first product that's being bricked because of a firmware update, but it sort of doesn't look good for me that does it.
Not a great start anyway.
Yeah,
Yeah.
that's a good segue, Yorick, I think, into the bad, and I think you're getting a little bit more excited about the bad points of this product.
Look, I always feel like I have to defend a product, and this time you're really defending SHA. Well,
So-
yeah,
Can I say, just to sort of as a coverall for what we're trying to get to at here, is that there is a difference I think tradies would know in the industry between going to Bunnings and getting a Ryobi drill and then going to trade deals and getting a Milwaukee drill or something.
you think this is a Ryobi? I reckon this was a Zito.
As or something even cheaper than a Ryobi. And I guess that's probably what we are trying to cover with these negative points. Is it's hard a little bit to put your finger on it, but a tradesman knows when he picks up a good drill.
Yeah.
But we will try to weed out what we mean by that.
Yeah, well, let's get into it. So, the first things first, the inverter. Look, you opened one up, and I think we'll put a photo up. But the first thing you saw, you were telling me, is that just how many little subboards inside, ribbon cables, ferrite cores. It just looked like it was a whole bunch of off-the-shelf parts that were just thrown into an.
Yeah, and if you've never looked at an inverter, you'd be just confused anyway. But if you pull apart, for example, the Gen 24, which we'll show a picture of, it's basically one big printed circuit board that all the components are put by machine onto that printed circuit board, and then there's a few connectors.
I reckon our iStore video would be a really good one to have a look at, because that one had a really good comparison between the two.
Exactly, yeah. And iStore is a really good example of one big printed circuit board. They basically, it's like they grab different printed circuit boards. These are not them, off the shelf, and sort of put them all together with ribbon cables and different cables. A lot more hands-on, less automated. A lot of cables, and when you've got this kind of design, you need those ferrite cores to stop EMF, interference.
Yeah.
And they had this real handmade sort of looking ferrite core, and 6 mil cable wrapped around it. All of these points are they're there for more failure. You get a lot more interference. You're creating a lot more heat with all these cables. It is just fairly obviously, it's sort of more of a backyard way. Backyard's a little bit harsh, but backyard way of making an inverter.
Yeah, well, maybe not necessarily designed from the ground up to be an inverter. Maybe they've used parts that they use in other parts of their manufacturing, and this is why I wanted to allude to the frequency controllers for the electric motors. They're probably taking some of those off-the-shelf parts and integrating them into their inverters.
It kind of is. Yeah, I don't know.
This is speculation. Yeah.
Literally, that's what it is. But it kind of has that feel that they grab this part and they grab these capacitors, these inductors on a board, and they kind of cable them all together, and somehow the inverter magically works. Yeah.
Okay, Mark. Well, let's get to the hard-hitting points. GMPPT, so Global Maximum Power Point Tracker.
Yeah, it doesn't have one. So that is what we, SMA call it shade fix. So it helps you in a shady situation.
Or dynamic peak management.
Yeah. Or so kind of a clutch or a gearbox to get you out of a shady situation. It doesn't have that to start with. But not only that, we did some testing on the MPPT.
Okay.
So by throwing some cardboard over some panels, sort of simulate shade coming over, and then taking it off. And so we've got 2 different arrays doing this, and we compared it to the Fronius inverter at exactly the same time. And it really just tripped up the SAJ inverter. So you kind of, it doesn't respond as quickly.
It's just very slow to react.
Yeah, which, to be fair, isn't unusual with cheaper inverters, but it just doesn't have as good of a response to dynamic changes in weather conditions.
Okay, no, that's really interesting. I'm assuming there are no AFCI, so arc fault interruption.
Yeah, a lot of inverters don't have AFCI, so if you have a burnt out plug on your roof, it's not going to detect that and trip. No. That's no surprises at all. But yeah.
And look, I know you're a big fan of fans, Mark, especially Fronius fans. I thought you did some testing on temperature between the two.
Yeah, so this was a really interesting one. Is that we don't have, so up on the roof here, we don't have that much power. I normally test 5 kilowatt inverters.
Okay.
So I've got around about 8 kilowatts. Or 16 kilowatts, 8 kilowatts for one array, for one inverter, and 8 kilowatts of another array of identical solar panels. I need to upgrade that one day. So we were testing putting 8 kilowatts on the Fronius inverter, 8 kilowatts on the SAJ inverter, and we put a temperature probe into both of them. We'll show that picture here. And even running before the fan, the inverter even heated up and needed to use the fan, it was running sort of 10 or 12 degrees hotter, just
Okay.
at really low light.
So Fronius didn't even have the fan kick in, and the SAJ is cooking.
Yeah, exactly. So comparatively, like you can imagine if this thing is trying to discharge the battery really quickly, running 24/7, heating up in the middle of the day, it's really going to just start heating up so much more. Let's say maybe 20, maybe even 30 degrees hotter. And what do we know about the rule of thumb with power electronics, Joris?
So I think it's like every time it goes up by about 10 degrees, the life of that system or that life of that component is going to drop by about half on average.
Yeah, so we can't expect, I don't think, this inverter to run anywhere near as long as a quality inverter like Fronius. It's
Yeah.
just what it is. Yeah.
Talking about not lasting very long, what happened to our first SAJ inverter? I mean,
So
why do we have two?
that was kind of a funny one. So when we're doing these tests, these shading tests, we're changing out arrays all the time, switch this array over to that array and stuff like that. So I just told Tack, my apprentice that helps me out with a lot of testing, can you run down and undo that MC4 plug
Yep.
and change it over to the other array? So he went down to unplug it and I've done this 1,000 times. Right. Technically, you shouldn't undo a plug when it's under load.
An apprentice, gotta give them a rake.
But no, I do it all the time. You can get away with it. It's completely fine. But he undone it and said he saw this massive banana arc
Okay.
as he undone it. I don't know why I did that, but it blew up the inverter. The inverter stopped working. We got SAJ in and they had to replace the inverter under warranty or whatever. So a little bit concerning that we somehow blew up an inverter just by doing what is a fairly normal thing to it.
Yeah, okay. Well, at least they replaced it. I think that's a big tip. So, look, every inverter these days has an app. Monitoring is a vital component of every solar system these days.
Mm.
Look, I'm going to throw some mud here. I don't love the app. I think
Yeah.
it's very clunky. It does the job. I mean, the homepage is fine. You can see where the power's going, but I just found it really unintuitive. And I was actually speaking to our mate in the industry who has the 30 kilowatt hour, 30 kilowatt SAJ system,
Yeah.
and he said to me, it's clunky at best.
Yeah, he doesn't like it either. I don't care. It was fine to me. It did everything that I needed it to do. Mav, who's our apprentice, who we installed it for, he was fine with it too. I guess it's your expectation, but you do really like an intuitive, nice app.
Well,
it's not that.
It's a touch point. It's
Yeah.
the thing that you're going to be interacting with. I'm not going out to my inverter and looking at the screens. I look at my app, and I want it to be straightforward. I like it simplistic, but I feel like that definitely could choose some work. Now, Fronius is not perfect at their app, but
Yeah,
I feel like
a lot.
this was very messy, unfortunately.
Yeah. Now let's move on to the battery, Yorick, because you've got some concerns about the battery too. Should we lift up the case? Yeah, let's lift this up. Oh, so we've emptied this. We've taken 2 stacks of batteries out of it.
Yeah.
And so have a sort of a look at that case, how it's just sort of welded together, sheet metal, bolted on handles.
I reckon that's powder coated steel.
It kind of, as I've sort of said before, it's like me and my engineering buddy from school got together and made it down the shed down the back. Actually, I couldn't do that good of a job.
No, no.
But you
I
know
was
what I
thinking
mean.
your engineering skills are very good. But look, it definitely has a sort of a rack mounted battery feel to it, a little bit of a DIY feel to it. And it's just little things. So, we'll get into a few points, but like just using things like Anthanol connectors, RJ45, like Cat6, Cat5 connectors. One of the things we see in all, higher end batteries, and we're talking Fronius, we're talking Sig Energy, we're talking BYD, you name it. They're all using these floating connectors here. So basically, you've got one connector that sits in between the 2 battery modules, and then as the battery stacks come together, they interlock and all the connections are done.
Yeah. We do have RJ45s Fronius actually for the reserver.
Yeah.
But I do know what you mean. So you're just putting one brick on top of the other.
Yeah.
Proprietary sort of plug. Rather than just sort of getting off the shelf from
You know.
RFI or something.
Yeah. You don't have an RJ45 for every single module. It's just for the BMU.
Yes, exactly. Yeah.
Yeah. So that felt a little bit sort of, as I said, rack-mounted batteries, sort of DIY off-the-shelf components. Look, this might be very nitpicky, but SAJ have 2 battery modules. The HVB, so not HVB, has the 2 battery modules. The B2 HV1 and the B2 HV5. They look identical. We ended up having to get a battery module replaced, and this is why we've actually got one pulled apart. So we needed to get an extra module. We needed to have balanced stacks, and we put the same purchase order in, and they sent us the first time HV1. We did the stack, and then we added a HV5 module, and it bricked the battery module.
Yeah. So it didn't actually brick it, but it kept on playing up
Okay.
for Mav. But Yeah, you keep on carrying on about this. I think this is more of a logistics problem from One Stop that we got it from. No big mistake.
Yeah, so another thing that came up was it has to be connected to the internet. Some companies have had a bit of flack for this. Again, SOC Energy comes to mind. But if your SAJ battery is not connected to the internet for more than a month, you have to let SAJ know. Otherwise, it drops your warranty from 10 years down to 5. Now, that is a pretty harsh warranty condition because I know many people who will just turn off the internet when they go on holiday. Now, not everybody gets to go on a 6-week holiday, but it has been known to happen.
Yeah.
Do not turn off the internet.
Yeah, yeah. I thought that was a little bit of a harsh clause. Whether they'd use that against you or not, I don't know. But, you know, I don't like dirty clauses in warranty documents.
They're just loopholes.
Yeah,
Yeah.
exactly. Now, can I talk about the BMU?
Yeah. Let's get into it.
Yeah, okay. So we keep on getting comments on videos that we mentioned too much that one particular company.
Okay.
So in this video, we're not going to mention energy.
Oh,
Okay.
you're not going to mention energy.
No. So, but there are some other modules that batteries that have these DC to DC converters. And what they try to claim is that it doesn't matter if one battery is running different from another battery, because you've got DC to DC converters, they're all independent of each other.
Yeah.
And so what they're trying to infer is it's a little bit like what they try to infer with solar panels. If there's one that's running lower than the other one, it's just going to drag it down and you're just going to have inefficient panels.
I've heard this story before. I think, wasn't that Solar Edge?
So that's why you put optimizers on panels too. And it's ironic that you're using the same name, optimizers, in these DC to DC converter batteries. Well, it's stupid because all that optimizer is doing, as we've proven, and you can look at the figures up here that we've got, is it's losing maybe 20% more power by optimizing it.
Yeah.
So what we actually do in high voltage batteries, in all of these kind of batteries, is have these BMUs in them. And BCU, BMU, or whatever you want to call it, the industry gets mixed up with what they're called. But basically, you've got a little BMU on each module, and you've got a big BMU on the top.
Yeah.
What we'll have here, and one thing we can point out, is that with a BYD, we've got this printed circuit board, which is used for looming all these cables together.
Yeah, whereas in this case, it sort of feels like what I'd see in a car engine bay, where it's all been done sort of by hand, tied together with.
Very manual. We do prefer this way of doing it, but then this is picking up. This is your thermistor, so this is picking up temperature and voltage points from every cell. So where is the temperature sensor within a battery? It's basically on the cell of most of the cells they have.
And why do we have the temperature sensors, Mark?
So we want to know if a battery is getting too hot, or let's say we're charging it really fast at 10 kilowatts and that battery is getting hot because it's out in the sun or because the battery is getting cold. It'll derate the charging, so we're not damaging the battery, because batteries don't like to be charged when they're hot or cold, for that matter. So temperature sensor and voltage sensors are important because that's for charging too. We know a battery, when it gets to around about 3.6 volts, it's fully charged. When it's down to 2.8 volts or something like that, it's flat. So this is how the battery knows what rate to charge the battery, when to stop charging the battery.
And how to keep the battery healthy.
And it goes one step further than that, Yorick, because what these other batteries are claiming is that we're going to have cells here that are different than the cells there. It's a pretty simple fix, as it turns out, is you put a little resistor in the small BMU inside every battery, and you trigger that resistor. So let's say this cell here is getting 100% charged when the other ones are only 99% charged. You put a resistor on that. You can tell by the different voltage it's at. If it gets to 3.6 volts, you put a resistor on it. It flattens it a bit while the other ones are charging up, and you can balance the cells that way.
Yeah.
So we already have passive cell balancing built into every battery. Now, it is interesting, though, that not all BMUs are created equal. Sure.
No, not at all. So I think this is actually quite an interesting thing. So when we've been doing our round trip efficiency testing, we know that it's hard for a BMU to figure out what the battery state of charge is when it's sort of in the middle of its charge cycle. It uses fully charged and fully discharged to do its calibration, essentially. But what we're seeing, which we don't see a lot in other battery systems, is as the SAJ's batteries discharging slowly, it'll suddenly drop and then continue and suddenly drop. And it's as if it's recalibrating itself midway through its discharge cycle.
And we do get that with Fronius when I put in my new reservoir stack because I was watching it really closely. We did get that on the first cycle that it jumps as you were trying to balance all those cells and the battery's trying to learn what state of charge it is at.
Mm.
So you do see that for a new battery. We cycled this one many times and discharged it. You're only going to really see it when you're doing these tests. So we're discharging at 300 watts for like a 36-hour period, and we're seeing the 300 watts is consistent, but the charge rate just corrects itself all the time.
I wonder if it's not very good at Coulomb counting, which is I know how most of the batteries tend to figure out what state of charge they are at, or if it is just doing an on-the-fly calculation. But I doubt that would be the case.
Yeah, and I was talking to SunGrow today as well, and this is sort of the thing that I can't really test, but you kind of just know it to be true, is that the same way as Fronius has a better GMPPT, a better algorithm built in with it, that secret sauce, different companies can have better BMU algorithms. And when you turn on that resistor to discharge the battery, when you get to 90%, do you slow down the charge rate? How do you know when it reaches 100%? What is 100%?
Yeah.
Or what do you do when one of the cells is running a little bit hotter? All of that secret sauce is what makes a better BMU from a cheaper BMU.
And also too, understanding what the state of charge is really critical for the longevity of that battery module or battery cell.
Yeah.
And that's where when we spoke about with other brands about the smarter that BMU, the longer that battery is likely to last.
And so I guess I'm making a few assumptions here to be fair, but when you look at a battery, and this is a fairly old model of a battery,
Yeah.
right? But when you look at a battery, that the design is just so much more well designed compared
Yeah.
to this sort of
On
design.
like an engine bay, as I said, yeah.
You go, if they put this level of attention into building this, and it came from BYD, what level of attention do you think these guys put into their VMU research?
Yeah.
And we've heard from different engineers, Solax using AI in their BMUs, talking to SunGrow about how they've cracked how to use these resistors a little bit better. That really is secret sauce in the industry.
Yeah.
And you kind of get the feeling that the secret sauce in this one isn't that secret.
So, Mark, we've thrown a lot of mud at SAJ, but why don't quality companies like ourselves install these cheaper brands?
Yeah, so it's a little bit hard to know. Like, we're assuming that this isn't a quality product, right? Look, we've been in business 17 years. How long have you been with us? Over 10 years.
Over a decade now.
Yeah.
Yeah.
And I think you get to know that you do have to look forward to the next 10 years, not just to the next paycheck or whatever it is, right? If you have to be worried. We made the mistake of installing far too many SolarEdge, 130 systems, and we had to replace more than 130.
We've learned the hard way,
We have learned the hard way. I think it is just companies that are concerned about the future, that really understand they want to install good products for their customers, and just a lot more conservative in what they choose.
Yeah. I mean, the way I see it is, look, a quality installer is going to take a long-term view for you as the customer. They want to be able to support you if anything goes wrong. And part of that is ensuring that you've got a service team, but also you're selling proven, reliable products so that your service teams aren't overwhelmed with just having to replace inverter and battery after inverter and battery.
Yorick, I think we're starting to waffle a bit here.
Oh, yes, Sarge.
Yes, Sarge. Over and out.